Hello everybody, today is the first ever Scientists from the Past reunion convention. Over here we have John Dalton. He just come from the time machine. How was the ride?
The ride was very unpleasant, but what can you do? There ain't that many time machines, I say.
That's a funny joke. Well, we're gonna talk to him about his Dalton atomic theory. Now tell me, Dalton, how long did you live?
Well, I was born on 1766, and I passed away, because obviously now I'm a ghost. Passed away in 1844, so that makes me 88 years old, I say. And I think I am pretty old.
Tragic indeed. Now, Dalton, what did you discover?
So, as you know, I've discovered that all matter is composed of small indivisible particles that cannot be created nor destroyed. And I am telling you from my point of view, no one on this planet in history is going to discover something better than my discovery. So
we'll see about that. Oh, Double JT, we're here together here at the...
Here together here?
Can I call you that?
Hello.
Yes, you can. It's okay.
Oh, thank you. Okay, now we're here to talk about your plum pudding model that you come up with here in your 83 years of life. That's impressive indeed. Now tell me.
So now, as people know, I'm an English physicist, and I discovered this because I use a cathode ray tube. And once I put a beam in the cathode ray tube, at the end I knew it bent. And once I looked at that bent showed me that there's negative charged electrons. And looking at that, I know now that electrons are surrounded by positively charged solid. So I use an example of a chocolate chip cookie. You guys have it here. We have cookies also in Britain, where the chocolate chips are the electrons and the dough is the positively charged solid.
That's a good analogy. We can all appreciate that.
You smart, you loyal, you grateful. I appreciate that.
Hello everybody and welcome back. I'm here with Rutherford. Now tell me, Rutherford, you look like a lot like my boy, Double JT. Tell me, are you guys related?
No, not at all. He's English. I'm not English. I'm from New Zealand, and yeah, no.
Now tell me, your fashion choices intrigue me. What's that all about?
Well, as you can see, I have 2 gloves, but if you look a bit deeper, I have 3 gloves.
What?
And I'm calling this my new invention, the double gloves. It's gonna come out in the 20th century.
I predict it will sell well. Now tell me more about your nucleus model, also known as the planetary model. Tell me more why it's called the planetary model.
So the planetary model, it's because how I've discovered that there's a nucleus, and the sun represents the nucleus, and how all the planets orbit around the sun. That's why it's called the planetary model.
How did you figure out about the nucleus? What did you have to go through?
So I got a stream of alpha particles and I emitted them to a thin layer of gold. And once I did that, I realized that it reflected the gold thin layer reflected the alpha particles, and that's how I figured out that there's a nucleus.
You smart.
All right, everybody, welcome back, and we're here with Bohr. He's the last, definitely not the least, of the scientists. Tell me, Bohr. Tell me more about your model.
So
Boring.
okay, as you know, that my model is that there's different energy levels, and in those energy levels, it consists of a certain amount of electrons. Now, those electrons are orbiting around the nucleus, and the nucleus consists of protons and neutrons, which is generally all the mass of an atom, most of it at least.
Orange juice isn't that good, but it's kind of good.
It's such a nice day. Ew, that's so acidic. What?
Oh, bro, if that's acidic, maybe you should neutralize it.
Yeah, can you get me some base or something that has like a base in it?
Oh, good idea. I got some bleach.
Whoa, no. Look at that. Look at the women's symbol.
Yeah. Hey guys, it's late night editing. I'm going to talk to you guys about women's symbols because we didn't actually do it in the video. Now, you see women's symbols. Our workplace hazardous material information system. It's used all around Canada in workplaces for dangerous things like Easy Off, heavy duty oven cleaner, stove cleaners as well. I think. There, see that women's symbol right there? Corrosive. If I spray some on my hand, well, it's not corrosive. Maybe it is. I spilled some bleach on my khakis earlier. You see that? Like, that's gone. I just did that a few minutes ago. That's gone. You know? So. Oh, also right here, too. I don't know what's gonna happen to my hand now. Let's just wait. Okay. So yeah, WHMIS. It's Workplace Hazardous Information System. Yeah. To the lake, yeah.
So we're about to go to the lake, and we're gonna
go do something. We finished our first 2 scenes. We're gonna do something pretty cool and keep on watching.
We're gonna test the purity of the water.
Okay, guys, me and Ayman are now here at the lake, and we're ready to take our water sample. Alright, beautiful day, beautiful lake. Alright, here, Ayman's gonna take out some water.
Well, we gotta do the ritual first.
Oh, what the hell is it? Okay, yeah.
Satan. Satan.
Okay, get ready. Okay, now, as you guys can see now, this is 2.5 grams of water, or 2.5 milliliters of water. Now, people might think that, well, this is obviously, water is H2O, and that's the element of water. But that's pure water, and this is not pure water. So as you guys can see, there's plants here, there's dirt, there's rocks in the middle.
Wait, look, I'm gonna do that. You see that powder right there?
Yeah. There, obviously there's dirt, and then there's ducks, and there's several different ways that the water can change its element.
It can be diluted.
It can be diluted, and yeah.
Oh, what'd you just throw?
Okay, that's that. Okay, guys, now for this experiment, we have 2 glasses of water, of lukewarm water. We have salt, and we have this weird looking spice that I honestly don't know what it is. Okay, now Ayman's gonna show us for the salt and water.
Alright. So, we're gonna put this, we're gonna get a gram of salt.
Half teaspoon. Struggling.
The struggle.
Okay.
Alright, well.
Now he sprinkled it inside the water. Now stir it.
No, but seriously though, we gotta put some more salt. Alright. Okay, we got some salt in there. You see that? You know, mixing it in the water.
Now
You see it's dissolving.
Now, yeah.
Dissolving. Okay. Now that's spinning.
Okay, so now as we can see through this glass, we could see on the bottom that there is still some salt. That salt is only caused, that precipitate is only caused because we put a bit too much salt. But otherwise, the salt dissolves in water. Why
well,
is that?
You can see that the salt. There's a cloud over here. Look at the pure water. See, you can see the difference. It's cloudy over here. That's salt. Over here, that's actual. It's just straight up water.
Yeah, so this one is highly soluble. So salt and water is highly soluble because a precipitate is not formed. Here, now my turn. Now, I don't need this. I'm gonna take this weird looking spice. I honestly don't know. Oh, it stinks. I'm gonna take this and I'm gonna just dump it in. So as you can see, it's not really sinking because it isn't heavy enough. But as you can see, like that salt, it's not gonna dissolve because it is solid. But this is sort of a precipitate. It's not really a precipitate, but
I don't know if that counts.
I don't know if that counts. But the salt. But keep on going. Keep on going. We're not done. But if we put some salt in there, a bit of salt. That's a lot of salt. We put a bit of salt. Now, look on the bottom.
Wait. Before we look at that, look at this.
Look at this.
Water.
Salt is dissolved.
You don't see it.
So now there's no precipitate caused, and that is because of this.
Look closely. You don't see no. Oh wait, there is some because
There's some a bit. But look at this. Now look at this one. This one, I call it my own salt and weird looking spice cocktail. Here we go. Now look in the bottom. Come here, look at this. Get it pretty close. You can see that obviously there's a salt precipitate down here. And this shows that this compound right here, this water and salt and weird looking spice, has low solubility and it causes a precipitate.
Yeah.
Quick, like that. Keep it like that. Okay, in front of me. Okay, so we have these 4 questions, and it's gonna be who wants to be a millionaire. So we have some prizes, and each question you get correct, you get more prizes. But if you get one question wrong, you lose all of it.
Okay, I understand. Yes.
Okay, you ready?
Yes.
So we're gonna start with the first question. So the first question is, name 4 elements from the periodic table.
He knows, but I
He
don't
knows?
think I. Oh yeah, he's in science.
Yeah.
Yeah,
If
he's
you
in
want, if you could
science.
help her, that'll be awesome.
Do you want the letters or elements?
No elements, like
You can give
whatever.
us both.
Yeah. So like whatever, it's just 4 elements from the periodic table.
My son would know, but I don't.
Lead, tin, silver, gold.
Okay, there you go. First question correct. There you go.
Thank you.
No problem. So do you
Next.
wanna go to the next question
Oh,
or
yes,
take your
please.
prize?
Oh no, I'll go to the next question. I'm
Next
very
question.
curious.
Okay. So
But they're hard.
now, what is the chemical name for salt?
Sodium,
Sodium and what?
or something.
Yeah, chlorine.
Chlorine.
Okay, there you go.
I see
Now-
that sometimes on jars.
Yeah.
Yeah.
Okay, now another question. There's gonna be 2 questions left. Is bleach an acid or a base?
It's a base.
A base. There you go. Okay, final question for the big prize.
That was a hard question.
Name 2 scientists that have contributed to write the modern atomic theory. We'll give you some people. So Bohr, Thomson, Dalton, or Rutherford. One of them. So it's
For the atomic?
yeah, atomic theory. The one that we use today.
Well, it's probably Thompson, but I don't know.
Thompson.
No?
The
It's
answer incorrect. The answer was Bohr. But thank you, and you still do get your.
Couldn't find a prize.
Oh,
Yeah.
Okay, how about
No,
this? How about this?
thank you.
The prize is a high five.
high five.
High
Yeah.
five. There
And
you
to
go.
you too.
Yeah.
Thank you very much.
Thank you. Thank you for
Thank
your
you, thank
time.
you. Bye.
Thank
Okay.
you. Bye.
Assalamu alaikum everybody. Now we're going to be explaining the 3 main key terms from chapter 1. They are ionic compounds, molecular compounds, and polyatomic ions. Now starting off with ionic compounds, Ayman's now going to explain to us what they are.
Alright, now let's say we have lithium. It has 1 valence electron. We're going to put that right there. And then we get fluorine, whatever. It has 7 valence electrons. We're going to put them like we would for a electron dot diagram. So you make pairs until you can't make pairs, basically. So over here you have lithium, and over here you have fluorine. So for an ionic compound, would get the 1 valence electron from lithium, and it would transfer it to fluorine right there.
So it can have a stable octet.
So now it has a stable octet because it's 8. And then here are the first energy levels valence electrons for lithium, which is 2. So now they both have a stable octet because they both have full energy levels that are occupied.
And finally, for the last definition, polyatomic ions. Now, polyatomic ions consist of 1 or more different atoms which are joined by covalent bonds. Now, an example for a polyatomic ion is nitrate ion, which is NO3. Now, nitrate it consists of 1 nitrogen atom and 3 oxygen atoms. Now, these 2 elements are joined by covalent bonds, and now this is gonna be how it looks if a covalent bond occurs. So right here they would just be bonded together, and that is basically what the definition is for polyatomic ions.
Adding on to the covalent bonds,
For the covalent bonds, there would be a slight a line sort of that brings the valence electrons together. Basically, the electrons would be on that.